Kubernetes Security Learning Series point of view. 24th topic is use audit logs to monitor access. So as usual, I'm in a training.linuxfoundation.org CKS syllabus, and if I scroll down under monitor and logging and runtime security, the last topic is use audit logs to monitor access. So here two things. One is audit logs, second is monitor access. Right. So let's try to understand. So as we know, in the Kubernetes point of view, so let's say if we deploy any YAML file by using a kube configuration file, so we will hit the API server, right? First authentication phase, authorization phase, second, and the third one is the admission controller, and then finally it will store into the APS etcd database, right. But here in this topic we are trying to use the audit logs to monitor the access, right? So what is audit? Audit is like what happened, when it happened, who initiated, on what did it happen, and where it was observed, and from where it's initiated to where it's going. So basically when it comes to the audit, purely we will talk about the access only, right? Say if you have a 50 or 100 pods and something happens, and then you need to know like who happened, when it happened, who initiated, what request happened. So this is a kind of audit. So our goal is here to use the audit logs to monitor the access. So we need to access the audit logs first. So Kubernetes, apart from the before the slide what we have seen, Kubernetes supports an audit as well. See if I go to the Kubernetes official documentation, right, and I'll type audit, right, just simply, so auditing, it will take you to the auditing page, right? What is auditing? These are the points just now I show, right? Then so we need to understand the Kubernetes audit architecture, how the auditing will happen. Let's say you have a 4 different Kubernetes actions. One is you are trying to deploy one thing and want to edit, and you wanted to delete one secret, and you wanted to patch one particular service by using this kubectl patch command. So technically these 4 are the request. What request? HTTP request, right? Not post or get, post, delete, right? Patch and all, they are HTTP requests. So it will go and hit the API server, right? I did the kubectl apply if, and then immediately it will does the processing and store it into the etcd database, and immediately you will get a response that yes, deployment is created. If you are edited, then config map is edited. Deleted means yes, secret is deleted. Patch means yes, this patch has been done, something like that. Some response it will come, right? But here our objective is the audit. With respect to the audit, Kubernetes maintains an audit handler. So this audit handler is maintained by the Kubernetes API server. What it will does is here 1, 2, 3, 4 requests, HTTP requests, right? In technically, these HTTP requests, for every request means here 4 requests, it will maintain a stages. So every request it maintain a stages. And what are the stages? One is a request received, second is request started, third one is a response complete, fourth one is a panic. So means when I do this action, these 4 stages will occur internally. For this. If you go to the official documentation, right here, request received, response completed, panic. Here, now let's go back here. Request received. Whenever you apply this, then this particular request received. Request started. Whenever it receives the request, then that will happen. It is there in the documentation as well, right? Request started. And the response complete. When the response complete, when the response body, right, when the response body is sent, then this particular event will happen. And panic is nothing but it's an error. Whenever an event generated, when panic is generated, which is nothing but an error. For this each stage means this 4 step of stage will happen for every request. For every stage there is a audit policy if you define, right? Means here every stage will generate an event. Means whenever is this request is received, you can configure an event. What is the event? That event in the form of a audit policy. Here audit policy is nothing but is a set of rules. That rule may be none, metadata level, request level, or a request response level. Means what? First, metadata. Whenever any of this stage occurs, during that stage you can capture metadata information. Metadata is here only just who is the user, what is the timestamp, on what resource, and what is the action, get, post, and not request or response body. Now it is a request. Request is basically it's a event metadata and request body only. Since it's a request only, it will capture what request, this guy on which this stage, right? Now request response, fourth one. Request response means API server is received this request and as well as a response, both. What is the none here? Did not log events match this role. Means if you specify as a none, it won't log. Let's say I don't want to log for any configuration any patches happened on the Kubernetes service level. So patch is nothing but it's a verb. Service is what? It's a resource, right? Something like that you can define for any namespace. And once this particular event, what you can do, you can send this particular audit information to a file or a webhook. So ultimately is what? This is the source, this is the stage. In this stage you can configure audit policy, and that ultimately audit policy is in the form of a log file, which is in the form of a JSON. And also I don't want to do it for the file, but I wanted to do it for a webhook. Yes, you can configure the webhook. This is the how architecture it will work. Now here the key point is audit policy, and of course the today's topic is audit policy, and here the audit logs by using audit policy. So this is a log file ultimately. Now audit policy. So audit policy is a simple, it's a YAML file. Here if you look at here in the official documentation, this is a YAML file, and first it's a policy looks like this, and kind is a policy, and its level, it's a metadata. As we see, right, in the previous slide there are 4 types. So first is a metadata I am showing. Metadata is a level, you have to specify a metadata. And here what is this example is talking, I wanted to capture the metadata on the production namespace for secrets and configuration maps. This is an example which I taken from a documentation and modified just to explain in this video. This is a resource and this is a namespace. Now second type is a request, right? Here go here, it's a second is a request. Request is what? Request body. I wanted to log request body when somebody create, update, watch, delete list on the configuration maps in Kube system namespace. I wanted to log. This is the another audit policy. And another one is request response, which is the this guy. So what it is? Request response body and event metadata. 3 means combination of 3, right? Here this is the one, and resource on what resource? On the pods, and I did not specify namespace. Yes, if you don't specify, it will applicable to all the pods, all the namespaces. And here omit stages, since these events are generating from a before stage is a request received. So omit stage is something like I don't generate audit event from the this particular stage. So that's how you will configure, right? And the fourth one is a none. right? This, what is this none is talking about here? Don't log the request for the configuration maps. Means if anybody modifies or this does anything on this configuration maps of test configuration map, don't log any audit, because I don't care. That's what the its purpose. If you don't want to log any of the, say if anybody watching the endpoints or services, don't log the watch request. So here in the official documentation, these comments are there. Whatever the comments you are able to read here, so everything is there here. So I have taken this example to show, right? This is the what. So 1, 2, 3, 4. So basically here the audit policy point of view 1, 2, 3, 4. These are the 4 key points. Now, how to implement this audit policy? As we have seen what is audit and its stages and audit policies and this one. Now, we have a Kubernetes cluster and master and 2 worker nodes. This is Kubernetes. First, you will be creating a audit policy YAML, which is something like this. Whether you want to add a request response, metadata, none, or request, anything you can add, or you can combine multiple things. It's your choice. That's the first thing. It's a second, what you will do, you will configure an audit policy at API server level. That's the second step you have to do. Third step is, yes, you will configure audit policy, but where you will store the audit logs, you have to configure that one as well as a third step. And fourth step, you will configure the audit file and audit logs, but how the Kube API server will know where the folder is? That folder has to be mounted. These are the mandatory steps. And say along with that, I wanted to call some webhook, right? Something like a AWS Lambda or anything you can configure. And this audit file, where you have to create, just only on the master node. Everything you have to create the audit policy on the master node. Configuring in the API, of course, API server is located in the master node, and audit logs, yes, in the master node and API server level, and mounting, yes, on the API server level. But auditing is, it's a external auditing. So I wanted to call a webhook of say GCP or AWS Lambda or anything. So this is how you will be implementing a audit policy. Now, Kube API server level configuration. As we have seen in the previous slide, 3 places: audit file configuration, audit logs, mount policy, and webhook as well, also at API server. So API server configuration is a very critical, I would say. Now, in the API server level, there are 2 mandatory configuration. First is audit policy file. Where is the audit policy file is located? I have pasted my audit file in etc Kubernetes. Under that there is a folder called audit. Under that I renamed as a policy1.yaml. You can give any name. And where I wanted to pump the logs, I wanted to pump the logs into etc Kubernetes audit, same folder. Now, there are 3 optional settings where this particular log file, how long you want it to keep, what is the backup size, and what is the maximum size. Maximum size is in the form of a MB. And if you go to the official documentation, so log backend, what is the log backend specific details? These are the 2 mandatory fields, and as well as and the rest of the max age, max backup. So max age means define a maximum number of days and maximum number of audit log files, and maximum size in the form of a megabytes, where you will be defining here in the command level. And here you have specified the path to audit file and log file. But how the Kubernetes will know this particular folder? You need to mount it as a volume. This particular is a new folder. This audit folder is not exist. Right? Kubernetes should know. Here you have to specify as a host path of this guy and give a some name, and same has to be volume mounted to the container level at the Kubernetes audit, and read only false. Why? Because this log file has to be right in this folder, right? So in this folder, k8s audit.log file will be generated. So once it is done, then that's it. Your audit logs will be generated. And maybe you can ask how the sample audit logs looks like. This is how I have generated. It's in the form of a JSON file. Maybe if you have a Python or any other logic, you can just parse this and you will be able to understand a complete detail. This is the here metadata. This is request response. What metadata contains? Who is the user, right? And what is the source IP, user agent, everything, just metadata information. But request response is much more detailed, right? This is how the details of the request and request response is contained. This request response is for the different intended on the metric server it generated, but if you applied on it with a specific condition, then such kind of a JSON will be generated. Now the next is, so far we have seen this auditing by using a Kubernetes feature. Also this auditing can be possible by using a Falco audit rules. So as I have explained a detailed video on the Falco, maybe I will give this link in the description. Please go and watch that. Here basically the point is, if you wanted to achieve Falco audit rules, just search it. It will take you to the Falco documentation, and Falco is nothing but it's a Falco rule, and where Falco you can create a Falco audit.yaml file, and this is the rule, Falco rule, and where you can specify the what kind of auditing you want, and you wanted to tell in the form of a warning, and the warning will be thrown to you as a audit. But in the previous step what we have done is that's auditing into some particular file. So it's your choice what is the approach, but Kubernetes audit is this one, and now it's a demo time. I am in a 2-node Kubernetes cluster, one master and one worker node, version 1.23. So as a first step, create an audit policy file in the master node. So what I will do is I will go inside the master node, right? I will go inside the master node, right? And my master node is Ubuntu 21.0, which is the latest, and I'll just log in as a root user, right? And now clear. So first step is I have an audit file, which is this is the audit policy file, right? First step is a policy YAML file. This is the audit policy. So one is a request response, one is request, one is metadata, and other one is all metadata. So here first point is I wanted to log a request response of all pods and namespaces, and the third one is request. I wanted to log a request of pods in dev namespace and default namespace. So only namespace condition I kept for the request only. For request response I want for all pods, and metadata for secrets, config map, services, deployments, service accounts, all metadata I wanted to log and catch all the metadata at the all request level metadata, right? So what I will do is now I will just copy this, right, and go to the master node. I wanted to maintain etc Kubernetes and ls. I wanted to create a folder called audit, right, and cd audit, right, vi say policy 1.yaml. I just wanted to keep the simple name, right, and just paste it here. Simple, it's a audit policy file, and just I will save it. Cat policy 1.yaml, perfect. My policy YAML is created. Now just is the only file, and what I will do is I will just do the pwd. This is the policy, right, and cat, this is a full path. I just wanted to copy. Now I will go back to the cd manifest, which is all the Kube API server is there. So before that what I wanted to do is I wanted to take a backup of a Kube API server. cp, I just wanted to take a backup to home/vagrant slew kube api.yaml. I just wanted to take a backup. Yeah, right, perfect. Now I wanted to edit the Kube API server, and this is my path. Edit, right? Yes. Now go to the official documentation, right? And what is the where the flags it's given here? here these two are the options, are the important. So I'll copy these two and as well as these three as well. So what I have done is I have just copied here these 4 values and go to the API server level, right? And this is a Kube API server, and I will enter a new line, paste, right? Here I have to make sure I'll just quickly edit that. The last one, yes, these are the file. So my folder is etc Kubernetes and audit, right? Now the first step is done. Go to the slide, audit policy, yes, audit policy file also I have configured, and audit policy file, audit policy log location as well, which is the same. Then mounting is the third step is remaining. So mount is nothing but this particular is a new folder, right? So and I will go down here, right? Volume mount here, right? So here I have to mount a one volume which is same like this, right? But here I'll open right here, new line and just paste here. But my name is audit, volume mount name is audit, and what is my folder name is audit, folder name audit, right? This is my volume mount, and it should not be read only. Why? Because log files will be written. So and I have to make it false because this must be writable. And the last step is a volume, which I have to create a one volume as well, which is same like this, right? Like same like a certificates, right? So here I paste it here, and here my folder name is audit, which is a very simple, maybe you can use anything, and the name is audit, right? Perfect. Kubernetes audit, this is audit, AUDIT, and volume mount is here, AUDIT audit, and this will be referred back here, and it's perfect. 3-step process, this is the most important. Now I will just save this file, right? And I just wanted to make sure cat kube API server .yaml file, I wanted to check whether it's correct or not. So this is my policy 1, right? And I will go here, cat my policy file, yes, perfect, its location is there, and cd double dot and cd audit folder ls, right? So now I just modified, so I need to wait a few seconds to my server to be up, and it's still not down. I will pause the video. I wait for a few seconds, and now when I open, yes, my cluster is up and running. And when I go to the ls, then there is a audit log file is generated, ls-l. So if I specify ls-l k8s audit, which is just created 822, right? It's a 422 and 822, just a few nanosecond back. And I wanted to just verify kubectl describe pod and my Kube API server. If I describe here, yes, my audit policy is this one, my audit log is this one, log is pumping into this particular directory, and it's a volume mounts, of course it's there. Without volume mount it's not working. Now the actual time will start, right? Clear, right? Now tail -f k8s audit log. Now see, this is my audit log, is keep continuously happening. What I will do is I will try to just delete this is not required, right? This is my policy file, right? I created. So I will try to create a namespace so that it will capture a request and response. So I will go to the another window. So kubectl create a namespace, and here any namespace, right? So dev namespace I will create. Kubectl get namespace, yes, dev namespace is created. Now then in the default namespace or dev namespace, if you create a pod, the request will be logged, right? Now kubectl run web1 --- image equal to nginx, and in the dev namespace, Yes, it's created. And kubectl dev web 1 pod I wanted to create in the default namespace as well, just to track. Now number 2 is completed, right? It's already going on and it's continuously pumping the logs. And metadata, if you create a service accounts and all, it will create, right? So just you can create anything. I think these two are enough to check the logs and all, and config maps as well. Say kubectl get config map, right? This is a configuration map. So yeah, I think it's fine. Now I will go back to the server, right? And what I will do is it's continuously running. So cat Kubernetes logs grepher hyphen dev namespace, right? Just now I created dev namespace, right? Perfect. You see here there is a lot of JSON, and what I will do is I will go to the Google and JSON viewer. There is a JSON viewer. This is a JSON format viewer, or like a JSON viewer, right? And there is a best JSON viewer. Anything you can take, anything, but I will take this one, Code Beautify, which is a very good one. So this is a right. So if I just copy this, right, it's copied the full JSON response. Yeah, right. Not the, maybe I'll take something else. Yeah, this one. It's a very simple. It's a metadata. I copy this, go to the JSON viewer and paste it, right? So this is Beautify. So this is my metadata which is created on the worker node 1, and this is my IP address, this is a namespace, this is a web 1 pod. So in this way it will create a logs, and there is a request response as well. So if you look at the level here, level is a metadata, and here search for level, right? This is a metadata. So this level is a request response, right? Say if I copy this particular request response, this is a very big, huge, right? But still I wanted to just copy, right? And I will just replace this guy, right? Oh, yeah, of course I will paste it. See, this is the request response, right, of get, and these are the details. And what is the response object? This is the response object, and it's a very big JSON format, and whereas you can just monitor what happened and everything in the cluster. So this is how you can basically verify. And one thing is, good thing is, you can configure a webhook, maybe you can lambda or any other thing, so that it will trigger. This is the way you can achieve the use audit logs to monitor access. Here purely talking about the monitoring of access. So all access is nothing but here under the basically the verbs you have to specify. So if you look at the right verb, get, create, update, watch, delete, anything you can configure. And last but not the least, here kubectl explain, right? Oh, there won't be any documentation for this. What I will do is, here this is a policy file, right? And policy, if you go to the API audit.k8s group and API group, right, if you click here, it will take you to the policy object, which is yes, that's what the is a policy, right? Then under the policy, where I configured under the rules, right, under the rules, this is the policy rule. Under the policy rule, see users, you can specify for which users you wanted to configure the basically the log audit here, or else user groups. If it is a Linux groups, you can configure, or verbs are nothing but like where you can configure get, edit, update, list. These are the API verbs. And resources are nothing but Kube API resources. Namespaces, which namespace you wanted to restrict, and omit stages. This omit stage is the one of the key where you need to drill down more of the omit stage, whereas it will omit if you specify. And there are many more where you can configure here, source IPs and all, user agent and all. So you can configure much more as if you wanted to keep the simple auditing. This is enough, and where you wanted to more granular level, just go and add the YAML file. Yeah, that is all about the audit implementation. I hope this session is helpful. Thank you. Let me know your feedback in the comments. Bye bye.